about today is we're going to talk about temperature, and we're going to talk about temperature conversions between different temperature measurements and different temperature scales and things like that. So, first thing we need to talk about is we need to talk about what the different temperature scales are. Okay, and there are 3 temperature scales. Okay, 3 you say? Yes, 3 I say. Okay, now the first temperature scale is degrees Fahrenheit. Degrees Fahrenheit is dumb, stupid. It is an imperial unit. I apologize to the rest of the world that we are still using imperial units, but we are still using imperial units, even though they're dumb. Okay? Because the Fahrenheit temperature scale has absolutely no basis whatsoever. Okay? Really doesn't. Doesn't mean anything, just random arbitrary numbers. Okay? But the freezing point on the Fahrenheit scale is 32 degrees Fahrenheit. Okay, the boiling point is 212 degrees Fahrenheit. Okay, again, yeah. Celsius. Celsius is the metric unit of temperature measurement. Okay, and again, it's measured in degrees Celsius. All right, this one's starting to make a little more sense, whereas the freezing point of water is 0 degrees Celsius and the boiling point is 100 degrees Celsius. Again, we got nice little factors of 10, all that kind of stuff. But here's the thing, that's a little bit arbitrary too. Why are we using water? Why didn't we use rubbing alcohol? Why don't we use oxygen? Why are we using water? Okay. Well, water is a very common substance on the planet, and so that's something that's easy to measure, and the freezing and boiling points are relatively achievable, right? It's easy to get things to 0 degrees, and it's easy to get things to 100 degrees. So water makes sense, but if you think about it, water is actually a really, really, really scarce substance. Okay, liquid water is very, very scarce. Now, not on Earth, obviously. Most of the surface of the Earth is covered in water. Okay, but if you go outside of the Earth, all right, if you go out into space, into other planets and things like that, there is no liquid water. All right, very few planets or moons or anything that we found have any amount of liquid water on them. So basing it on water, not the best basis either. So what we have is we have our SI unit, our international system, or Le Système International, okay? And that is the Kelvin scale, all right? The Kelvin scale does have a basis. It has a concrete basis to it. Now, a couple things I want to point out. Notice, Fahrenheit is measured in degrees Fahrenheit. Celsius is measured in degrees Celsius. Kelvin is measured in kelvins, not degrees Kelvin, just Kelvin. The Kelvin itself is a unit. Okay? So, when we measure things in kelvins, we just say 273.15 kelvins. All right? Now, freezing point of water on the Kelvin scale is 273.15. Boiling point, 373.15. Now, do you notice anything about those two numbers? I hope that you do. Okay, you notice that they are exactly 100 degrees apart from one another. Okay, so basically, it's the Celsius scale, but it doesn't start at the freezing point of water. It starts somewhere else, right? Because there's 100 degrees of separation just like this. What that means is 1 Kelvin and 1 degree Celsius is the same measurement. Okay, same increment. Okay, same change in temperature. If you change 5 degrees Kelvin, you changed 5 degrees in Celsius. Okay? Did I just say degrees Kelvin? Oh, bad me. If you change 5 kelvins, you change 5 degrees Celsius. Okay? Don't be bad like me. All right. So, we'd said that the Kelvin scale has a different basis, a different starting point. Okay? And this is not an arbitrary starting point. The basis of the Kelvin scale is what's called absolute zero. Okay, so temperature is a measure of the average kinetic energy of the particles. We talked about how the particles are all moving around all the time, okay? But what happens is as the temperature decreases, the particles move less. They start to kind of slow down. Their kinetic energy decreases. Well, it stands to reason that at some point they would stop moving, okay? That point is referred to as absolute zero. Okay, absolute zero is the temperature at which all of that random atomic motion stops. Okay, and so absolute zero is 0 kelvins. Now, can you move slower than stopped? No. Okay, because you say, oh, but you can start moving backwards. Well, if you're moving backwards, you're moving and you're not stopped. Okay, so absolute zero is the foundational basis of the Kelvin scale. That is the coldest temperature that you can achieve. All right. So what we need to do is we need to be able to convert between these temperature measurements. Okay, Celsius to Kelvin is really pretty easy because, again, it's the same increment. The only difference is the starting point, right? So what that means is, if you think about it, the freezing point of water is 0 degrees on Celsius and 273.15 degrees, or 273.15 kelvins, right? Not degrees Kelvin, right? So that is the same temperature, 273.15 Kelvin and 0 degrees Celsius. So what that means is, all you got to do to change from Celsius to Kelvin, add 273.15. Okay, take your degrees Celsius, add your 273.15, round to significant digits, okay, and you have your Kelvin temperature. So on a nice day, the temperature may be 28.5 degrees Celsius. What is this temperature in kelvins? Okay, well, in kelvins, if your Kelvin temperature equals your Celsius temperature plus 273.15, okay, and your Celsius temperature is 28.5 plus 273.15, okay, and when you work that out and round to significant digits, keep in mind you're adding, so you need to round to the last known place, which is the 10th place, okay, and so that comes out to 301.6 kelvins, not degrees Kelvin. All right, so that's a conversion between Kelvin and Celsius. That's what you're primarily going to use in this class, because we don't measure things in Fahrenheit because Fahrenheit is dumb. So let's skip that. Okay, temperature conversions. So now we need to convert between Fahrenheit and Celsius. Okay, between stupid units and pretty good units. Not the best, but pretty good. Okay, so now the thing we notice here is that the difference between freezing and boiling points of water are 180 degrees Fahrenheit and 100 degrees Celsius. Okay, so if we take 180 over 100 and simplify that, we get 9/5. You can take a 20 out of both of those. Okay, so what that means is 5 degrees Celsius is the same change as 9 degrees Fahrenheit, and that is an exact change. All right. So then, once you converted your change to Celsius or to Fahrenheit, then you simply change the starting point. The Fahrenheit scale starts on 32 degrees. Okay, so mathematically, we express that this way. We say that the Fahrenheit temperature equals 9/5 times the Celsius temperature plus 32. This is exact. This is exact. Okay, so again, your significant digits are going to come from your two temperature measurements. All right. So 329.9 kelvins is what temperature in degrees Fahrenheit. Now, I didn't give you a conversion from Kelvin to Fahrenheit, all right? But I did give you a conversion from Kelvin to Celsius and then Celsius to Fahrenheit, didn't I? Yes, I did. Okay, so what we have to do is we have to go through a middle step here, okay? So if my Kelvin equals Celsius plus 273.15, okay, then Kelvin minus 273.15 equals Celsius. All right, so 329.9 minus 273.15, so I've got 56.8 degrees Celsius. Now what I've got to do is got to change that into Fahrenheit. Okay, well, Fahrenheit equals 9/5 times Celsius plus 32. So 56.8 times 9/5 plus 32 gives me 134.2. Because I've got one decimal place here, I should have one decimal place there. Okay. In general, with significant digits with temperature conversions, that's what you're going to look for. However many decimal places you have in the measurement is how many decimal places you're going to have in the conversion. Okay, because both of them involve adding and things like that. So, we end up with 134.2 degrees Fahrenheit. All right, so those are your temperature conversions. You need to be able to convert from Celsius to Kelvin, from Fahrenheit to Celsius, Fahrenheit to Kelvin, Kelvin to Fahrenheit, all those different conversions in between.